Okay, good afternoon. All right, so this is week 13 of the ELEC 1013 network cabling class, Fanshawe College, London, Ontario. There we go. Here's the announcement. All right, so quick housekeeping things. This is week 13. Week 14, there's going to be no new theory content. It's just going to be the test. And I'm just need to announce, just make sure that please have all your work submitted by the end of week 14, because the next day, which was going to be August 16th, I'm going to input the final grades. So make sure all your dots are crossed and T's are I'd and things like that, right? Right. Yeah. And the test is going to be I released the test, the final test, just before the weekend. So you're going to have the weekend to complete that, and plus the rest of the week. Make sure you do that, because we just, the term is ending, so there's not going to be even possibility of reigniting anything, not like we do it anyways. So yeah. So today is going to be the second part of this week, and the first part is already online. It's a broken week because we lost the Monday this week because of the holiday. So the first part is already online. So please watch that. If you have any questions, you know how to find me. As far as labs, tomorrow, what's the announcements here? Yeah, in the announcements, there is a schedule for the labs. So Wednesday is already gone. We are Thursday. So this Friday, this lab is quite short, the last final lab. So if anybody has anything to make up, don't wait for the next week. Just go ahead and show up, and I'll take care of you if you want to use that as an open lab as well. Okay. So, and here's the list of the labs. So, Friday. And for the next week, here's the list of the labs. So next week is an open lab. So anyone from any section, just join in any of the sections, and we'll take care of you as far as any outstanding work that you need to do. Okay. I don't see that too many people have any outstanding work. However, some do. So don't waste that week, because, the time is ending. As fun as it was, all good things come to an end. Right? All right. So today, second part of the of this week's presentation, and this one is called what do they call it? Tools and equipment. What an infrastructure technician, according to the job, performed. So the first part already is there. So please watch that. Second part. Here is the, just a little bit of a review. Every project is broken into basically, sometimes there's certain deviation one way or another, but basically that's what it comes down to. There. Basically what every project comes down to is survey, assessment, site work, commissioning, and billing. Survey is basically going, and I go over the first part, but survey is basically going on site and seeing what you need, what equipment you need, what challenges you're going to encounter, and what other things basically this whole assessment of the site from the angle of what needs to be done. Some things might have to be replaced, some things might have to be added, what equipment you need, what tools, maybe extra tools, maybe there's going to be some lift that you're going to need to order, extra ladders or extra drilling equipment, who knows, and maybe some wiring has to be replaced. So all the survey notes, and survey can last half an hour, or it can last a whole week depending on the job. Assessment. So based on the survey notes, you can do the assessment, which is basically preparing a quote. Already I'm covering that in the first part. Site work, well, basically then it comes down to doing the work, going on site and just performing. And commissioning is after you have installed whatever it has to be installed, after the whole thing is done, then you go and present the system to the client. Maybe there's going to be some instructions that they will need to operate the system. It's basically instructional session on how to use whatever new equipment was installed. And of course, billing is my favorite part. And so should be yours because you deserve it. Okay. Now, when it comes to site work, that's the second part. And I'm recapping a little bit, maybe as 1 or 2 slides from the previous presentation. All right. So the first stage of actually doing the work with this type of business is wiring. Devices will be installed, or jacks will be terminated, outlets, jacks. But wiring is a huge part of every job that we do. So what did I write here? After planning, cable distribution, which could be part of the survey, the rough-in stage begins. During that, all cables are pulled from the home run location to their destinations. Every cable goes somewhere and you need to run it from the home run location, the common LAN room usually, and to their destination. Could be a desktop outlet, could be a ceiling for the wireless access point, whatever, maybe somewhere in the wall. That's all included in the job description that you're going to be handed in by whoever hires you to do the job. The cables are coiled in bundles at both ends, but not terminated. So you run the cable where it's supposed to be or in an approximate location, and you coil them up to come back to it later. And of course, all the wires at the LAN room, also same thing. Sometimes you coil them up in the ceiling, and sometimes it's a lot of them, you coil them up and leave them on the floor. But when that happens, you just have to make sure that those cables are protected. You gotta make sure that nobody walks into that room and it's not going to step on your wires, depending on the dynamics of the job. Because sometimes you're the only people that are going to be entering the LAN room, so that's fine. But sometimes there could be other trades that will need to enter the LAN room where all your wires, where all your wires are, laying on the floor, and then they don't understand the importance of not disturbing the wires. There could be some millwork people. There could be some even electricians. They will step on your wires. Other trades, whatever. They will not read the little signs that you say don't step on the wire. They will step on the wire and then they will notice that sign. So make sure that you protect your wires. Usually it's hanging on, from some ceiling structure, and so you just have to be mindful of that. All right, make sure the cables are clearly identified at both ends. Of course, that's I'm trying to all through the semester or through the term basically emphasize the importance of labeling the wires on both ends. You need to know which wire is which. I mean, if you have 2 or 3 wires and if you forget to label one of them, you can quickly trace which one it is. But if you have 600 wires, they need to be properly labeled, so you don't have to lose time for tracing maybe 200 of those cables. That's unacceptable. It's that's time, and time is money, and literally time is money on the job site. So make sure the cables are properly, clearly identified at both ends. Then, when you're terminating, you might have to transfer the numbers from one point to another point on the actual cable in order to those cables still be identified properly after being terminated. But before that, you're just going to have to identify them so you can find them properly and you know which wire is which at both ends. Then what is here? All runs securely mounted in the ceiling space or otherwise. Raceways could be, and the work is done according to the local building and electrical code. So you have to also follow whatever rules and regulations of the law of the land. All right. Like, for example, all like when we are here, all wiring has to be independently suspended in the ceiling or independently suspended. Which means, like for example, if you have a drop ceiling, which means there are ceiling tiles resting on the on the frame, that frame hangs from the true ceiling on steel rods or steel rods, and you are not we are not supposed to, we cannot strap the wires to those rods that are holding the ceiling frame. It's part of the fire and safety regulations. And long story short, when God forbid there will be a fire, but if something like that happens, then the fire people go in there with those I call them the hooks on the sticks, whatever those things are called, or whatever else equipment they have, and sometimes they are required to tear down some ceiling structures and things like that. And if there are things that are strapped to those ceiling structures, it just makes it unsafe. So all the wires should be independently suspended when it comes to it. So that's just one of those rules. All right. So that's about that. Now the site with the rough-in, as I said before, the rough-in is a billable stage. When it comes to billing, do not have one final bill after the job is done. That's not practical. For example, reason number one is that some of the jobs take longer. What are you going to do? You have to pay, if you hire some people, you have to pay them. You need to buy the equipment, and so you don't want to wait for that money that long. Also, the other main reason is that unfortunately, from time to time, some of the big contractors or small contractors, they take their time to pay, and they find some weird excuses. And what are you going to do? Take them to court? Yes, you can, but you don't want to do that kind of stuff because you're going to lose all your friends. So, as I say, as people say, that good fence makes a good neighbor. On the same thing, make things nice and friendly. Have this thing included in the contract, bill in stages, and some of the companies will bankrupt, and you will never get the money because if somebody bankrupts, your job is done, your equipment is mounted, you have paid your people salaries, and you're going to end up with nothing if somebody bankrupts. But if you bill in stages, if towards the end some company goes bankrupt, you still at least have the money up to date. Maybe you're not going to get it paid for maybe its final stage or something, so you're going to lose some money, but not all. All right, site work. Continuing. Cable installation begins with establishing pathways, and this is a recap from the previous presentation as well. So free air runs and raceways. Cables can be run free air or raceways. Free air would be, well, like this on J-hooks. That's a free air run, which is, the cable is not in the pipe, not in the conduit, not in an enclosed tray. Or you can run them in the closed raceways, which would be conduits, pipes, closed cable trays, and so on. So, well, there's certain rules that apply to both, depending on whether it's a cold air return plenum or not. Let me quickly explain what a cold air return plenum is, if some of us still don't know. So here's my board. Okay, so let's say there's a floor of the building. Here is the ceiling and the true ceiling, and this is the floor of the next floor. All right. So over here, what we have is we have those rods on which the ceiling tiles rest. All right. And so on. These are the ceiling tiles. And here's an empty space. This is called plenum. Plenum right here. Plenum. Now, there's two types of plenums. There's cold air return plenum and not cold air return plenum, just a regular closed plenum. So what's a cold air return plenum? Let me just start with the other way. What's not cold air return plenum? There's somewhere, let's say these are 3 rooms. Okay. Room number 1, room number 2, room number 3. Notice that the plenum is shared by all 3 rooms. Of course, there are doors and locks and all that stuff to all the rooms, but the ceiling space is open to all 3 rooms, for example. Okay? So usually when there's a furnace or the HVAC or the climate control or heating and cooling, what they have is they will be having closed venting that is pushing the air in. Right, there will be registers, and there would be things that are pushing the air in. The air goes in, so that's considered the hot air, right? And there would be, you could see some so-called registers, and you can see that it's a vent. All right, so that's the supply air vents. Now, in order for the air to be circulated, there would be the take-up vents or return vents. And usually, if it's a closed system, quite often there will be a grid somewhere on the wall, all right? And that is connected right to back to the furnace, right? So here's the air going this way, air going that way, and that's an enclosed system, all right? Now, let's take a look at another scenario here. I'm going to grab my eraser. And, well, no. All right. Forget that now. The supply air is not in enclosed pipes, but somewhere in the ceiling, in the plenum, there will be a huge intake cavity. And that intake cavity is going to supply the air back to the furnace. Okay. Now, of course, because it's a negative pressure created, so there's going to be a suction created. So maybe in one part of the ceiling, there's going to be a supply vent, and somewhere further, there's going to be another, just a grid. Instead of a ceiling tile, there's going to be just a grid, open grid. If you shine a flashlight through that grid, you're going to see the true ceiling there. So that's a common intake vent creating negative pressure or like suction. So the air from the room is being sucked in, right, just through those grids. And from one of the common area, that air is being returned. So that's called, because the hot air is being supplied and the cold air is being returned. So that's called this whole thing here. If that's the case, this is called a cold air return plenum. What is the challenge with that? The challenge with that is if there is a fire somewhere, see that's a fire, okay, in one of the rooms, through those open grids, there could be toxic fumes entering the grids that are connected to other rooms. If there's a fire, and if the fire gets into the ceiling as well, the wires can catch on fire and can produce toxic fumes that possibly can enter other rooms. So in this case, different type of cabling has to be implemented. If it's a cold air return plenum, the cable has to be rated FT6. That's the FT6 cable. So that's the cold air return for cold air return plenum, FT6 wire has to be implemented. And FT6 wire is about roughly 3 times more expensive than the not FT6 wire that is rated. And the FT rating for that is FT4. It's just a regular insulation that can burn. If it's a cold air return plenum and you want to use FT4 cabling, it has to be inside a conduit. then you can use FT4. If it's in the wall, like a cinder block wall, yes, you can have that portion to be FT4. But then as soon as it enters the ceiling space, then it has to be enclosed in a pipe. Uh, if it's a free air wiring in a cold air return plenum, then you have to use FT6 cabling. And the inspectors pay close attention to that. The inspectors' eyes are so keen on that they could just look and say, oh, that looks like FT4 cable. It should be FT6. They will make you pull that thing out at your own cost, and you still have to fulfill the contract. You're going to have to reinstall this. So it's going to cost you way much more. If you're trying to get away with that, please don't, right? Because it's going to create all kinds of unpleasant situations, and financially unpleasant situations as well, because you can get fined for that. So that's as far as, and the difference between the FT4 and FT6, besides the price, because FT6 is about 3 times more expensive than the FT4 cable. Well, the FT6 doesn't burn as quick as it will still, like anything is going to burn, right? But it takes much more temperature for this thing to start burning, and and sometimes it's not going to burn at all. So the only difference physically is the jacketing that is used on the cable. Specifications of the cable, same type of a twist, same kind of twisted pair or not twisted pair or whatnot. So that's the same specs, same rating as Cat 5, Cat 5e, Cat 5, Cat 6, and so on. But it's just the jacketing, and the jacketing, when you touch that by touch, it feels like more brittle, more hard type of jacketing. And this one here, FT4, is the jacket feels softer, more flexible, that kind of stuff. Right? So as far as the FT rating, and that's one of the most important things when dealing with the free air runs or in a raceways. And in the raceway, yeah, okay, if it's an open tray, well, it's considered a free air run. So let's just summarize this whole thing, just make sure that I didn't miss anything. So free air runs, main runs should be kept in the bundle, suspended independently of any ceiling structures. As much as possible, establish straight runs, so pulling multiple cables can be done efficiently. Let's say there's a LAN room somewhere here, and there's going to be a bunch of rooms that a bunch of cables have to be installed in jacks, floor, monuments and whatnot, ceiling. So you just bring it roughly to the location. Now, you have to decide whether it's okay to bring it roughly to this location, and then you come back and just pull those few feet to the location, or sometimes, depending on the job dynamics, it's going to be better if you just pull it into the box and just coil it up there. You have to decide, because sometimes different trades come in at different times, and depending on, as I said, dynamics of the job. But if you establish straight runs, then you can use that run. You don't have to look for any kind of way, because sometimes the ceiling is going to be packed with all kinds of equipment, and it takes a little bit of energy to find a straight run. But if you establish a straight run, you can just supply the wires here, and you can pull it from here. So one person is feeding the wires, the other person is pulling the wires. So you can do it with 2 people. If you have to have bands and curves, then you're going to have to pull a slack here, lay it on the floor, and pull it there. So you have to do it in stages. So that's why straight runs are great. Plus, it's aesthetically more pleasing. An aesthetically pleasing job gets you another job by the word of mouth. J-hooks mounted on the wall or suspended from the ceiling. These will be the J-hooks. They're plastic, they're metal. Oops. J-hooks, where is that? Yeah. Mounted on the walls on the ceiling on threaded rods are the most common in this scenario. Other raceway types, such as conduits or cable trays, can be used as well. And sometimes you can get away with strapping the cables to the so-called red iron. What's red iron? What do we call it? Red iron. Sometimes you're going to have a ceiling structure, and I'm going to change the color to red. Okay, and it looks like this. It's a steel construction that looks like that. Okay, here, and there will be some railings that are connected. It's a ceiling structure. So yes, to that you can strap the wires sometimes. If you can get away with that, if it makes sense. All right. Raceways. As the alternative to the free air method, closed raceways or cable trays are used. All the raceways should be installed before the cables are run. Hint, position the J-hooks no further than 4 feet apart to avoid cable sagging. If the J-hooks are placed, let's say, all right, yeah, start a new page. J-hooks and wires, change colors. All right, so let's say this is pan. Let's say this is a ceiling, and you're going to have J-hooks suspended on threaded rods. All right. You have to have them no further than 4 feet apart, because if that happens, if it's further than 4 feet apart, the cables are going to start sagging. Okay. And what happens when they sag too much, this point right here becomes crucial, because you have more than one cable, there are a few cables, and right here, there's going to be so much pressure on the cable to the point that it's just like being stepped on for the cable, right? Those points. So 4 feet apart, no further than, and sometimes that 4 feet apart J-hooks, it will actually be written in the contract. So, okay. All right. Roughing in, continuing, threaded rods. Let me introduce you to some of the equipment that you'll be working with. All right. This is what a threaded rod looks like. Next time you go to some kind of home hardware, take a look at some threaded rods. There will be different diameters, different sizes, different lengths. You can cut them to length. There are different threaded rods. Sometimes there will be a specific length, and there's going to be a thread on part of it here and part of it on the other side, but usually it will be threaded all the way through. So you can cut them to length, and you can use them in different situations to mount all kinds of equipment. So what do they write here? A threaded rod is a relatively long rod, that is threaded on both ends or all the way through. The thread might extend along to complete the length of the rod. These are the best because you can cut them to length and use them as you wish. Right? And here are some examples of how the threaded rods can be used. If you go to the T1023, the big lab, not sure if you have still some lessons there. Along the side where the plumbing is, right by the desks, and there's some sprinkler section there. There are some, you can notice those some equipment being mounted using threaded rods. So next time you're there, just take a look at that. Strut channel. All right, it looks like this. You can also buy it in home hardware stores or Home Depots, Ronas, Lowe's, whatnot. They look like this, and they can be cut into pieces, and they can be composed in along with the threaded rods to create all kinds of mountings for equipment and such. All right. Now there are different types of strut channels. Will be solid channel, punched, halfway slotted, and half channel. This halfway slotted channel is probably the most common and that you can use. And again, you can cut that to length. You can cut in pieces. You can make cable trays out of that too. However, cable trays should be purchased as cable trays. Yes, they are more expensive to buy. It's more expensive to buy a cable tray that looks like a ladder, right? And that's suspended on the ceiling and used as a cable tray. Yes, those are a little bit more expensive than buying those threaded rods. But just and some company owners will think that they're saving money by telling you to make that cable tray out of that, not realizing that it takes time to do that. So it's actually going to cost the boss more for you to spend time and making that thing, because you have to cut things to pieces, you have to mount them on the threaded rods, and you have to use screws and bolts, nuts, and all whatnot. It all takes time. So it's just cheaper to buy the more expensive material and save on time. It's actually ends up being less money. And it looks nicer too. Now, over here, Strat channel, spring nuts are being used. Look at this here. All right. There's a bit of a spring nut. So this is a nut that rests on those two lips of that of the Strat channel. And over here is a thread, so you can screw in the threaded rod. And the top part is being held by against the top wall of the Strat channel, just to keep that in place. And you can quickly put as many of them as you want, once you download the presentation, you can watch. This is 45-second video or something like that, to actually show you how quickly and easy those can be installed. So these are spring nuts. All right. So what did I say about the Strat channels? Strat channel. Laser. Standardized form structural system, okay, mouthful, used in the construction and electrical industries for light structural support, often supporting wiring, plumbing, or mechanical components such as air conditioning or ventilation systems, or, other things that you might install, equipment racks, some whatever else. That it's a very common thing. Now, just I'm going to give you a pointer. Sometimes, in order to cut those, because this is tough, galvanized steel. Just remember, if you cut galvanized steel with the disc saw, so it's just like a chop saw, but there's like a disc installed on it to cut that, sparks are flying, which means enough heat is being produced to produce sparks. If you heat up galvanized steel, toxic fumes are being released. Beware of that. Use it in a ventilated area and wear appropriate PPE, such as masks. And N95 mask is not going to cut the mustard against those fumes. Where are we here? You don't want to breathe those fumes. Nothing is going to happen to you right away, but it's one of those creeper. Years go by, you might encounter some health problems, and you won't even know why you have those health problems. It could be because of breathing those fumes. All right, J hooks. What's the thing? That's what they look like. All right. You can mount them on the wall. You can mount them on the threaded rods. All right. So that's what they look like on the drawn picture, and you can cascade them to pull more wires, to place more wires in there. And when you buy those, there will be a chart on how many wires is this thing provided for, how many, it could be handling, certain size, because there are different sizes of the J hooks. Some of them are bigger, some of them are smaller, and they are rated for the number of wires and what type of wires that can be run through them, that can handle in one pull or one shot. And they can be cascaded like that, then it can be cascaded on the other side. And here is a threaded rod mounted with a clip to what? Well, that's what the red iron looks like. Okay, this red iron is painted white or off-white. Okay, but that's what we call it. This is the structure from the ceiling. Okay. Now, those J hooks can be metal, they can be plastic with Velcro, There are all kinds of different kinds, depending on the distributor, what's available, what's being sold. Mounting things. Sometimes you're going to have to mount some heavy things in the ceiling. Heavy as far as the weight, but even not so heavy thing. If it falls from the ceiling onto somebody's head, you don't want to have that. And you don't want to have a situation that you're going to install something in the ceiling and you're going to leave the site hoping that within 5 years, something's not going to become loose and fall on somebody's head. You want to sleep tight because guess who is going to be responsible for that once something happens? It's going to be you. And you can actually go to jail. Haven't heard situations like that, but it's a possibility. Plus, you just don't want to hurt anybody, right? So there's certain anchors that are available on the market. Plus, sometimes if you go to the distributor, they go, "Oh, we have that new anchor, and that's what it looks like, and that's that." And they'll give you some instructions on how to use that particular new anchor. But some of the basic ones, all right. So here is the threaded rod hanger. That's what it looks like. That's how it is mounted in a concrete ceiling. Now, those things are going to be rated for so much weight, of whatever the weight is. But that doesn't mean, it's a halfway information that you get from that, because the ceiling structure that you're going to mount this thing on has to be of certain strength as well. So it's just, it's a two-way street when it comes to that one. Now, true ceiling mounting examples. You could have a concrete ceiling like this. You use appropriate size of drill with a hammer drill. You drill that thing in and you screw that in. And there will be some. Is there a video here? No, but you can, if you know how to use threaded rods. What's this thing is called? I would encourage you to educate yourself a little bit further, okay, when it comes to this. And then no problem, you mount that, and you can just screw in the threaded rod, and to that threaded rod, whatever else is being mounted there. Oh, well, that's where we were right here. Okay. Sometimes you're going to get in a situation like this. Not a very pleasant situation because it takes way longer and way more expensive to do that, because there's a steel coating or covering on the ceiling, perforated steel. Yes, it adds strength to the ceiling, but it sometimes makes our life a little bit more than a little bit harder. Because to this one here, you just get a hammer drill, concrete bit, drive it in, and drive the anchor using proper procedures. Over here, first you have to puncture through the steel. So you're going to get not a concrete, you're just going to regular steel drill bit. And once you drill through it, you're going to hit that concrete. So you're going to dull up the bit. So you're going to go through a lot of bits. And then change the drill bit, drive into the concrete. And then, on top of that, there could be some other things that you really, really have to watch for. And what you have to watch for is that insulation, like a blown on insulation. Looks like a dry sewage or some paper pulp. Whitish, off-whitish, grayish kind of color spread on ceiling. What you want to avoid is this here, man-made mineral fiber. You want to avoid that. The fibers on that are small enough to go into your respiratory system, and they stay there. And according to some sources, they're just as bad as asbestos. Every construction site will have documentation on that, because when a general contractor goes in, they do their own surveys too. When they see that, There's another type of insulation that looks just like that. Let me see if I can quickly pull it, this thing on the screen. Um, Man-made mineral fiber. Click on images. Mm, in the ceiling. Can I see that properly? No, that's not what I wanted to see. Man-made mineral fiber. Come on, give me some good picture on that. Mm, there we go. There. Like, for example, that. It looks like a dry sewage being blown off in these dry. So it looks like the PPE that this person is wearing. Now, he's blowing this thing onto the walls, but it's also blown in the ceilings. You don't want, this is just a website that I got this thing on the fly right now. So here's a reference, okay? Da, 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 da. When you see that blown on the ceiling, you got to talk to the general contractor to present documentation for you, and they will have that. They will have that. If they don't, just leave the site. But they will have that. Now, there's another type of insulation, or different types of insulation that work just as well, and they are not man-made mineral fiber that are safe to be exposed to. Well, relatively safe. Nothing is safe. Right? You go on the street, it's not safe. um, so they're supposed to give you the information, and there is no way to tell, even by touch, that sample of that has to be sent to the lab, and the lab has to analyze it and tell that it's man-made mineral fiber or not. And sometimes that thing is blown onto the ceiling, onto this part. If it's a man-made mineral fiber, you have to educate yourself on that. See if you need the proper protective equipment, like a suit, specific type of a mask, and because it's seriously, you don't want to. You also don't want to breathe. You don't want to have this thing on your clothes. Usually, if it's just a blown on the ceiling, it can be done sometimes. And if you just walk underneath and this thing is just not being disturbed, it's called extra low exposure. But if you disturb that, fibers are going to fly in the air. You're going to breathe them. You're going to be considered as being in the high exposure zone when it comes to that. Enough said. All right. Extremely important. Extremely. It's a life and death situation. Now, other anchors, threaded rods. What is this? This one is called a drop-in anchor. Again, you can put threaded rods in there, but it's a different type of anchor. You drill a specific type of hole, and there's a specific type of mounting. You drill the hole in there, and then you do the insert, and there's a specific way of inserting that. You can have a tool that looks like almost like a chisel tool that fits right in there, and you hammer it with the hammer. But that's if you have one or two to do that, you can do that. But if you have 200 of them, then you should get a specific type of a drill. And if you can't buy it, you can rent it. It's a common thing to rent equipment with specific attachments for those. You drill those. It takes 10 times less time to drill those with that specific drill and the drill bit. And some of those drill bits are flippable. You drill that and you flip the drill, and then you have the driver in to drive the anchor in there, and you just press the trigger. Da, 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 da. It's being driven in, and you just keep mounting those, and you can drive the threaded rod into it or you can bolt and other things. And of course, you also have to assess what you're driving this thing in. If it's a soft type of like those things are rated for ridiculous amount of weight. However, what good is it if the ceiling is weak? So you have to make sure that the structure of the ceiling is actually able to hold that type of weight as well. So this is called the drop-in anchor. And here, click to watch. Once you download this presentation, you'll be able to do that. And if you're just watching this YouTube video 5 years from now or not, you can just type in that URL here. So this is a drop-in anchor. So we looked at the threaded rod hanger, drop-in anchor. Let's see. Also, quite popular and quite wide effective, very effective. Chemical bonds, chemical anchors. There are different chemical anchors, depending on the distributor, what they sell, what brand they sell. That's what it looks like. This is the side of a cinder block. You drive in whatever anchor, you put in that chemical bond there, and sometimes you have to wait 24 hours for this thing to set properly. That thing here, it becomes part of the structure. It is extremely strong bond. And again, there are different kinds, different brands, all come with specific set of instructions of how to use. Other things that you may encounter as working in this type of business is a 19-inch rack. Now, this is a floor rack. And with so many U's, you will have to count the holes because let's not get ahead of myself. All right, 19-inch rack. It's a standard. It's 19-inch in the width here. And here's the mounting rail. And here's the mounting rail, but it's covered by this chassis here. You can see that in our labs, where the oscilloscope and the function generators on the shelves are mounted. It's the standard 19-inch rack, except the equipment is not in the rack, but those rails are being held by the equipment, and the equipment is being held by the rails. Hey, win-win situation, right? But sometimes you get racks. You get floor-mounted racks. You got wall-mounted racks. You get racks on wheels. There are racks and racks and racks. Right? Some of them are vented. Some of them are less vented. Some of them, all kinds of assortment. All right, what did I say? A 19-inch rack is a standardized frame enclosure for mounting multiple electronic equipment modules. Audio equipment, very popular. Data equipment, very popular. Whatever else equipment, standardized thing. Each module has front panel that is 19 inches or millimeters wide. The 19-inch dimension includes the two edges of the ears. What are rack ears? Rack ears are this. Let's say there's an audio amplifier, commercial audio amplifier, all right? Okay, and let's say it's a 3D kind of a picture of the audio amplifier, and there could be a couple of volume controls, couple of indicators, and so on, and maybe there's going to be some venting here and whatnot. You will notice it's commercial amplifiers. Quite often they will have those kind of 3 holes with the screws in them. And there's going to be relatively small screws in there. In the box, you will get those rack ears, something like that. And those will have those matched right here and on the other side there, right? They will have those matched screw holes. You take those out, and those rack ears, these are called rack ears, and they will have 1 or 2 holes depending on the size of the amplifier. Is it 1U or 2Us? 1U is a 1 rack unit vertically, okay? You mount those on, so then you have the amplifier with the rack ears on both sides, and there will be mounting holes on those rack ears. So you could mount those into that frame, into those rails. What can we see here? This is a typical 1U. This is a 1U PDU. 1U, because this is approximately the size of 1, 2, 3 holes. It gives you one rack unit. Okay. And obviously, this one has the rack ears already mounted. PDU stands for Power Distribution Unit, which is basically a glorified name for a power bar. And it's a glorified functionality too. There are different PDUs that you can just buy them with a bunch of outlets on the front. You can buy them with a bunch of outlets, hydro outlets at the back, and maybe a couple of those at the front. There will be certain lightning or surge protection surge protection included in those. Some of them would be sequential power bars or sequential power PDUs, which means that if you want to turn that thing on, that's a whole bunch of equipment is being powered, and some of them are having heavy current draw initially, then you just blow the fuse. Right? So the sequential power bars or sequential PDUs are going to power up in sequence. This first, that, and it's just going to wait a couple seconds between powering certain outlets in order to not create a huge current surge when you turn the whole thing on. Right? So some of them are less expensive, those PDUs, and some of them are more expensive, depending on the functionality. Rack ears, okay, so rack ears that protrude from each side of the equipment, allowing the module to be fastened to the rack frame with screws, or they're called screws, rack screws. Now, the rails come in loaded or unloaded type of configuration. This is an unloaded frame because in order to be able to mount the rack screws, they're called rack screws, you need to put clips into those cavities. Some of the rails, instead of having those cavities for the clips, they will just have threaded holes with the specific thread that fits the rack screws. If you run out of those rack screws, find nearby music store, they will have rack screws. Where are we here? All right. Common uses include computer screw servers. Common uses include computer servers, telecommunication equipment, networking hardware, audiovisual production gear, and scientific equipment. It's all standardized 19-inch. Here are some examples. This is a wall-mounted rack. Here's a floor rack on wheels. And each rack has a specific way that things have to be mounted. And a lot of them, if it's in a LAN configuration, you have to ground that as well properly. So you just have to follow the rules of where you're going to install that. All right, so roughly the typical rail, that's what I'm talking about right here. This rail here, this rail here. This is part of the whole structure, but you can just buy the rails, straight rails like that. Take a look at those rails in our labs. And here's the dimensions of that. So see, 19 inches is from this edge to that edge right there. And there's some dimensions. So how many U's? Here's 1U equals 3 holes. Here's 1U, 2U, 3U's. So I think the oscilloscope that is mounted on those rails, it takes up 4 U's. Okay. When you're planning out the equipment and planning out the rack, you need to get the appropriate size of the equipment rack to accommodate the amount of equipment that you're going to use. So when you're buying the equipment or just before you buy it, count the number of rack units that the equipment is specified for to see if you can fit everything in a single rack that you're going to buy. If it doesn't, then you have to buy a bigger rack or bigger equipment rack. Okay? And this is what the rack screws look like. Some of them fit straight into the frame if this is just a threaded hole. If it looks like this, but if it looks like this here, then you need those clips. The advantage of the unloaded is that if the thread goes bad, and sometimes they do, you just take the clip out, bring a new clip, and you have a new mounting space here. If one of those loaded ones that is just drilled holes with the thread in them, if that goes bad, well, you can't use that anymore, right? So that's what the rack screws look like. Now, I'm going to leave that thing open-ended because the whole thing is, oh, wow, a couple of different examples. Here's a loaded with the threads, and here's with the clips. And quite often you're going to have plastic washers, so things are nice and neat. Um, so that's the last slide for the whole term. And I'm leaving this thing open-ended because you know what? This blues song never ends. Well, my friends had a dream. He told me about it. He was sitting in some kind of a room where all the famous stars who are not with us anymore, sitting with the guitars. The guy's a guitar player. And he had a guitar too, and they were playing some sort of a ongoing blues song, and things were nice. That's the dream he was talking about. And he told me that, yeah, okay, but every song has to end. So, well, wondering how we're going to end that song. So he kind of taps one of the guys beside him. So he goes, "How? Okay, so how are we going to end that song?" And that guy, whoever it was, turned to him. He goes, "Hey, this blues never ends." So, and that was a dream. Oh my, like my friend had a real. So, same as this here. I gave you certain amount of information, certain amount of knowledge, kind of a material that I gave you. Based on that, you can build on. Based on this, you can know you have some information of where to look for more information. Hopefully, you're going to get some experience. Based on the experience and additional training, this will never end. And if you work your whole life doing that, and you're retired after a couple of years, things are going to change so much that you're going to say, "Oh, I will have to relearn the whole thing again." So that's that's why the whole thing is forever open-ended, and I just throw a bunch of screws here at you, symbolizing that this thing never ends. Right? Cool. It was a pleasure to work with every one of you, and hopefully, when you see me in the hallways or something, if I don't recognize you because you know me, I do have that problem. I admit to that. So if that happens, just give me an elbow and say, "Hey, back, it's me." Okay. And I'm going to say, "Who are you?" No, I'm not going to say that. Cool. Thank you so much. And I will see you when I see you. When I see you.